testing. Right, today we're going to start on page 305. We have been discussing FOIL as a method to multiply two binomials. Two binomials in multiplication. And we call this our special product rules. For binomials. So with FOIL, our plan is I have a binomial times a binomial. And we know our process. Our plan is to multiply every term of the first polynomial times every term in the second polynomial. Every term in the first polynomial times every term in the second polynomial. But FOIL gives us that little bit of a tip. FOIL is first terms, outer terms, inner terms, and then the last terms. So we have a pattern to follow. So if I multiply the first terms, that's going to be x squared. Multiply the outer terms, that's all the way across out, plus 2/3 x. Your inner terms are those closest together in a binomial times a binomial. That's a negative 2/3 times x. And my last terms are those very last terms of each binomial. And I have a negative times a positive for a negative, and 2/3 times 2/3 would be 4/9. Now another tip or hint with FOIL is that we want to always look to collect like terms. So I have x squared. Here's a positive 2/3 x and a negative 2/3 x, which goes to 0. They're opposites, minus 4/9. So our pattern for multiplying two binomials using our special product rules of FOIL and collecting like terms to simplify. So with our eagle eyes, we want to spot or note that we are multiplying a binomial times a binomial. So I can use FOIL. Multiplying the first terms, I'm going to get x to the 4th. Multiplying the outer terms, that's x squared times a negative 0.3. My inner terms, it's a negative 0.3 times x squared. And my last terms, the negative times the negative is going to be positive. And 0.3 times 0.3 is, just be careful there, 0.3 times 0.3 is 0.09. You have those two decimal places to take care of. And with FOIL, we always look to see if we can collect like terms. And here I'll have a negative 0.3 x squared plus another negative 0.3 x squared for a negative 6x squared plus 0.09. So that is a pattern. We establish that pattern over and over and over again as a special product rule when we're multiplying a binomial times a binomial. Oh, I have a binomial times a binomial. I'm going to use FOIL. First terms be 21. Outer terms be a negative 15x cubed. Inner terms, negative 28 x, and my last term's a negative times a negative. It's going to be positive 20x to the fourth. Watch at my math lab, they may ask you to show in some type of order. So we'll rearrange to an order. Descending order on my x term, 20x to the fourth minus 15x cubed minus 28x plus 21. So FOIL, special product rule for binomials. When I have a binomial times a binomial. Well, now if you get out your blue cards,
Yeah, I can use it. I have it up there.
I'm sure. We want to look at our product formulas. And on the top of that side of your blue card, right away is FOIL. So our special product rules for binomials. And we have our form pattern. We have a binomial times a binomial. Notice that the first two terms are not the same, and the last two terms are not the same. So we can use FOIL on any binomial times another binomial. So our special product rules for a binomial times a binomial, we can use FOIL, and that's A plus B times the quantity C plus D. A is a term, B is a term in the first polynomial, C is a term, D is a term in the second polynomial. There's no indication that they are like terms. And FOIL, our first two terms, the AC, our outer terms, our inner terms, and our last terms. And then just collect like terms if you can. So that's our pattern established for using FOIL. Well, now we have some other special product rules for binomials. Remember, this is a binomial times a binomial. We could have the square of a sum or the square of a difference. This is on page 306. We can have the square of a sum, the square of a difference, or the product of a sum and a difference. So we have 4 special product rules for a binomial times a binomial. So let's look at the product of a sum and a difference first, which is on page 306. The product of the sum and the difference of 2 terms. The product of the sum and the difference of the same 2 terms. That's key. Remember, FOIL, the terms are not the same. We're looking at a special case now in our binomials where we have the same 2 terms. It's going to be the square of the first term minus the square of the second term. Our pattern is A plus B in the first binomial times the second binomial, which is A minus B, indicating that the first 2 terms are the same and the last 2 terms are the same. We have the product, something times something. We have the product of a sum. This is a sum, and this is a difference. The product of a sum and a difference is A squared minus B squared. And on our blue card, the product of a sum and a difference, A plus B, the quantity, times A minus B. I have the first 2 terms are the same, the last 2 terms are the same. I have a sum and a difference. My answer is a squared minus b squared. So we want now to familiar ourselves with these form patterns. That's the product of a sum and a difference. I mean, we all agree to that. It's something times something. It's a product. And I have a sum in this parenthesis, and there's a difference in this parenthesis. Looking up on my blue card, if the first two terms are the same and the last two terms are the same, and I have a sum and a difference, my answer is square the first term minus square the last term. So let's see if we can find an example. Well, we're looking at form patterns. So I'm going to set my form right on top of my problem at hand. And if I look that up, a plus b, the quantity, times a minus b, the quantity, the answer is supposed to be a squared minus b squared. So a from my recipe, from my form pattern, a in this case is equal to x. A's position is equal to x, and b's position is equal to 8. So now I can just transfer that to my recipe's answer. A in this particular case is x, but I need to square it, minus b in this particular problem is 8, but I need to square it. So I have x squared minus 64. Now that's using the form pattern. Why does that work? Well, let's check with FOIL. X plus 8 times x minus 8. Well, FOIL, that's x squared minus 8x plus 8x minus 64. Collecting those like middle terms, they're going to be opposites of each other every time. It's a pattern. You can count on it. That's why we want to memorize the form patterns. When I collect like terms, I end up with x squared minus 64. Square the first term and subtract the square of the last term. Sure enough. So I don't need to go to all of this FOIL work when I begin to memorize these form patterns. And you will use these form patterns through your college math career. There's folks that can testify to that. So it's important now that you use your blue card, and as we're continuing to explain the patterns, that you understand the patterns and why it's cleaner, neater, faster, more efficient to memorize your form patterns and recognize your form patterns and then apply your form pattern. So let's look at an example. Okay, I have x minus 7, the quantity, times x plus 7. And I know now that that's a binomial times a binomial. And I am learning that there are special product rules for binomials. When I'm multiplying special product rules for binomials. So I'm going to get out my blue card and just check to see. This looks like I have the same first terms and the same last terms. Here's a difference. Here's a sum. So I have the product of a difference and a sum, which is the product of a sum and a difference. So I'm just going to copy my recipe, my form pattern. And my form pattern says the answer is a squared minus b squared. So you can look at this, hopefully. The first term is a. I'm going to square it. Minus. The last term is 7. And I'm going to square it. There's your answer. And again, why does this work? Well, because FOIL works for any binomial times a binomial, so we can check longhand. FOIL, that'd be x squared plus 7x minus 7x minus 49. With FOIL, we always expect to check to see if we can collect like middle terms. Oh, and they're opposites, of course. We have the product of a sum and a difference. The middle terms cancel out. I get x squared minus 49. So over and over and over again, we want to recognize our form patterns and apply them, and we're much more efficient and faster as we work in more difficult problems in your next and beyond math courses. So this is theory. We're putting things in place for you as you move through your math career. So I find it real helpful to have my blue card here I can reference quickly. You can look in your ebook, all the formulas are there, but what page and what chapter. And so I've kind of tried to neatly present a few of these form patterns that we use over and over on a blue card. It's a crib sheet. You can use it for testing and homework and such, as well as your next math course. Oh, I have a binomial times a binomial. See, math is fun. Well, I'm going to get out my blue card because I know there's some special form patterns for the product of two binomials. And I have the first two terms are the same, the last two terms are the same, but the signs are different. I have a product of a difference times a sum. So here I have a plus b times the quantity a minus b. And my blue card says that my answer is going to be a squared minus b squared. So I'm going to apply this form pattern. In this case, a's position is 2x cubed. In this problem that we're working on at hand, b from my recipe, from my form, is 1. So a, in this case, is 2x cubed, the quantity. That's the whole term a. So I'm substituting it into my answer form pattern. A is 2x cubed, the quantity, but I need to square it. Part of my recipe is subtract. B's value is 1 in this example, but I need to square it. Two squared would be 4. X cubed squared is x cubed times x cubed, which is x to the 6 minus, and 1 squared is 1. So there you go. Now you can check this with FOIL. And loop-de-loop. And collect like terms to double check. But have faith. It's a pattern. It works out the same time and time again. Oh, I have a binomial times a binomial. I'm going to look at my blue card because I know there's special product rules for binomials. And I want to check, are the first two terms the same? Yep. Are the last two terms the same? It looks like I have the product of a sum and a difference. So my blue card says that my answer is going to be a squared minus b squared. I'm just going to lay my recipe right over the top and then determine a in this case is equal to x and b in this case is holding that position 4. So I need a, in this case it's x, but I need to square it, subtract from my recipe, and then b, in this case is 4, but I need to square it. X squared minus 16. Why? Check with FOIL, and your middle terms are opposites of each other, and they cancel out. Oh, I have a binomial times a binomial. I'm going to get out my blue card because I'm learning that there's special product rules for the product of two binomials. Are the first two terms the same? Yes. Are the last two terms the same? Yes. I have the product of a sum and a difference, so I'm going to use my recipe for the product of a sum and a difference. I'll just lay my recipe, my form, right over the top. And I'm feeling a little more comfortable now because I'm recognizing that if I work this out longhand using FOIL, the middle terms are going to be opposites of each other and cancel out. I have opposite middle signs, so the middle terms cancel out. Well, A in this case is 5, and B in this case is 2W. I need A, which is 5 in this case, but I need to square it. Pick up your form pattern, subtraction. I need B in this case, which is 2W. I'm going to protect that, but I need to square it. 5 squared is minus, and 2W squared would be 4W squared. You can check with FOIL. Longhand. Why? Have faith in your form. X minus 0.2 times x plus 0.2. Now, I just want to point out to you on your blue card, our pattern is the product of a sum and a difference. It doesn't say order. So we could have the product of a difference and a sum. Something times something, 3 times 4 is the same as 4 times 3. So we can have the product of a difference and a sum, or the product of a sum and a difference. That should not bother you. So sometimes you're going to see the difference first and the sum second. Order, multiplication, commutative property for multiplication. Terms can commute. So my pattern is a minus b times a plus b. And my blue card says, well, if that's the pattern, your result is a squared minus b squared. The first term in this case is x, and the second term in this case is 0.2. A in this case is x, but I need to square it, minus b in this case is 0.2, but I need to square it. X squared minus 0.2 squared, again, just be careful, 0.2 squared is 0.04. Remember the control on your decimal point. Well, let's check this one. We can always check with FOIL. First terms would be x squared. Outer terms would be 0.2x. Inner term is going to be a negative 0.2x. And my last term's 0.2 times 0.2, we decided was 0.04. And sure enough, your middle terms have opposite signs. So they will cancel out, leaving x squared minus 0.04. Oh, I have a binomial times a binomial, so I'm going to look at my blue card, and the first two terms are different. So if the first two terms are different, then I'll have to use FOIL. For my special product rules, the first two terms are the same and the last two terms are the same. So we know we have to use FOIL this time. I'll get x cubed, 3x plus x squared plus 3. And just check before you circle your answer. MyMathLab may ask you to show that in some type of order, typically descending degree order. Oh, I have a binomial times a binomial, so I want to get out my blue card. Are the first two terms the same? No. So we're going to have to use FOIL. Oh, I have a blue card. I have a binomial times binomial, so I'm going to get out that blue card. First terms are the same. Are the last two terms the same? No. So you'll have to use FOIL again. Oh, I have a binomial times a binomial, so I'm going to get out my blue card. Are the first two terms the same? Yes. Are the last two terms the same? Yes. Do I have the product of a sum and a difference? Yes. So I'm going to use the product of a sum and a difference, and I'll just lay my form pattern over the top. And I need to square the first term. The first term is x, square it, minus, square the last term, which is 4 squared, x squared minus 16. So recognizing your form pattern and making use of it. Increasing our knowledge regarding special product rules for binomials. On page 307. Square of a binomial. The square of a sum or a difference of two terms is the square of the first term plus or minus twice the product of the two terms and the square of the last term. So let's look at the square of a sum. This is a binomial times itself twice. A plus B, the quantity, times A plus B, the quantity would be A plus B, the quantity squared. Expanding that with our form pattern, we're going to square the first term, keep the sign, it's positive, and we're going to have two like middle terms that we collect. So we have 2 times the first term times the last term, and then of course we're going to square the last term. Whenever we square a term, whether it's positive or negative, our answer is positive. So we only really have to take care of this middle term. If it's a square of a sum, we're going to keep the sign. It's going to be positive. If it's a square of a difference, our middle term is negative. We're collecting 2 negative middle terms. So we have the square of a sum, which actually is a binomial times a binomial. It's a binomial times itself twice. So, oh, get out your blue cards. We have a binomial times a binomial. Looking at your blue cards, we have the square of a sum. And the square of the sum is, I'm just going to write down my extension. Square the first term. Keep your sign, we're adding. We're going to have two like middle terms, so a times the product of the first term times the last term, and then we square the last term. If I have the square of a difference, I actually have a minus b, the quantity, times itself twice. So that's a binomial times a binomial. First two terms are the same, last two terms are the same. If I square a term, it's going to be positive. I'm going to be collecting two like middle terms, but they're going to be both negative. So it'll be 2 times a times b. And then square your last term. The last term is b. If I square it, it's going to be positive. So I only have to take care of the sign of that middle term, and I keep the sign. If it's the square of a difference, it's going to be a difference. If it's a square of a sum, I'm adding. So now I just need to recognize some of these special case binomials. X plus 3, the quantity squared. Well, that's a plus b, the quantity squared. That's the square of a sum. I recognize it on my blue card, a plus b squared. I can expand it as a squared plus 2ab plus b squared. Square the first term. I'm going to be collecting two like middle terms. They're going to be positive. And square the last term. Whenever you square a positive or a negative value, it's going to be positive. So we don't have to worry too much about the sign. So let's see what happens. In this particular case, a is equal to x and b's position is equal to 3. Substituting into the result, I'm going to have x, but I need to square it, plus 2 times a's value in this case is x, b is 3, and b, but I need to square it. X squared plus 2 times 3 is 6x plus 3 squared is 9. You can check with FOIL if you want. How about the square of a difference? Oh, that's a binomial times a binomial. It's a binomial times itself twice. So I better get out my blue card. I know I have special product rules for a binomial times a binomial. This is the square of a difference. The square of a difference. So the square of a difference, I'll just write my recipe right over the top. The square of a difference is square the first term, collect two like negative middle terms, and square your last term. Well, carefully, A's position in this case is t. B's position in this case is 5. I need A, which is t, but I need to square it, minus 2. I need A again. In this case, it's t. I need B. In this case, it's 5. Plus B is 5, but I need to square it. T squared minus 2 times 5 is 10t plus 5 times 5 is 25. You can check with FOIL. Longhand, FOIL. The pattern works over and over and over, so we want to begin to recognize the form patterns and have faith that they work. So it's careful substitution into the form patterns. And you will need to know these form patterns moving forward in your math careers. So A minus 4, the quantity squared. Well, that's a binomial times itself twice, which is a binomial times a binomial. So I'm going to get out my blue card. And it looks like I have the square of a difference. I have the square and I'm subtracting the square of a difference. So I have a minus b, the quantity squared, is equal to, expanding that, I'm going to square the first term. I'll collect two like negative middle terms and then square your last term. In this case, a's position is equal to a, b's position is equal to 4. A, and I'm going to square it, minus 2 times a is a, b is 4 in this case, plus b's value is 4, and I'm going to square it. A squared minus 2 times 4 is 8, a plus 16. (2x plus 5), the quantity squared. Well, that's a binomial times itself twice. It's the square of a sum, so I'm going to look at my blue card, the square of a sum, and write down my pattern, a plus b, the quantity squared. Expanding that, the square of a sum, I get square the first term, collect two like middle terms, and square your last term. So identifying a's position in this case is 2x, b's position in this case is 5. So I can substitute. A in this case is 2x, but I need to square it, plus 2, a's value is 2x, b's value in this case is 5, plus b again is 5, but I need to square it. 2x times 2x would be 4x squared, plus 2 times 2 is 4 times 5 is 20 times x, plus 5 times 5 is 25. You can check with FOIL. (7.8) plus 1.2y, the quantity squared. Well, that's the square of a sum. The square of a sum, I'm just going to write my pattern over the top. Square the first term, plus we'll collect two like middle terms, plus square the last term. A in this case is 7.8. B in this case is 1.2y. So I can substitute. A is 7.8, but I need to square it, plus 2 times a, which is 7.8. B is 1.2y, plus b's value, 1.2y, but I need to square it. (7.8) squared, 60.84, and then 2 times 7.8 times 1.2, looks a little high, 2 times 7.8 times 1.2 is 18.72 times y, and 1.2 squared is 1.44. Y squared is y squared. Again, have faith in your form pattern. You can always check with FOIL. So we've looked at the special product rules for binomials. We use FOIL if the first two terms are not the same, or if the first two terms are the same but the last two terms are not the same. We use FOIL. Otherwise, the square of a sum, if the first two terms are the same and the last two terms are the same, we expand the square of a sum as a squared plus collect two like positive middle terms, and square your last term. The square of a difference, we have the first two terms are the same, the last two terms are the same. Square the first term, we're going to collect two like negative middle terms plus square the last term. And the product of a sum and a difference, we have a plus b times a minus b. The first two terms are the same and the last two terms are the same. We end up with a squared minus b squared because in FOIL, the middle terms are opposites of each other and cancel out. So carry your blue card with you now as we work through this chapter and beyond. Just put it in your study materials. And again, it's to be used for testing and homework and such. It's page 314. Page 314. Well, we have a little game to play on this page. Factors and sums. And we've identified product. Remember, product is our answer when we multiply. Factor is something times something. Factor something times something, and then sum. So what we're doing in this case is looking for our answer when we multiply to be 40, and we have a pair of factors. 5 times 4 would be 40, and 5 plus 8 is 13. So the game, we are factoring 40, looking for factor pairs whose sum is 13. So 63, we're trying to factor 63. Find two factors, something times something equals 63, but the sum of your factors is 16. Well, 63, we can factor as 1 times 63, 2, 3 times 21, but 3 plus 21 would be 24, not 16. The 6 go into 63, 5, 7. The 7 go into 63, 7 times 9. 7 times 9 is 63. 7 plus 9 is 16. So we've factored 63 using the factor pairs 7 and 9. 7 times 9 is 63, and 7 plus 9 is 16. Next, we're asked to factor 36. Find factor pairs whose sum is negative 20. Well, we have 1 times 36, but adding that is 37. 2 times 18. 2 times 18 is 20. How about a negative 2 times a negative 18? A negative 2 times a negative 18 equals positive 36, right? Factor pairs. And a negative 2 plus a negative 18 is negative 20. So my factor pairs are negative 2, negative 18. Remembering we have to control sign. We're on page 314. There's a game that we're playing. We're looking for factor pairs of 72 whose sum is negative 38. Well, 1 times 72. But if I add 1 and 72, I get 73. 2 goes into 72. 2 times what? 2 times 36. 2 times 36 is 72. But I need to have factor pairs when I add them equal negative 38. So negative, negative. A negative 2 times a negative 36 would be a positive 72. If I add my factor pairs, I have a negative 2 plus a negative 36. I get negative 38. Another one, negative 140. I'm supposed to find the product, negative 140, with factor pairs whose sum is negative 4. So I'm looking for factor pairs of negative 140 whose sum is negative 4. Well, a negative 1 times 140 would be a negative 140. If I add, I get 139. Not quite what I'm looking for. 10 times 14 is 140. I need a negative 140. 10 times a negative 14 would be a negative 140, and 10 plus a negative 14 would be 10, negative 14. Okay, you see the pattern? So on page 314, there's a few more of those patterns to look at as a game, and I would suggest that you try to familiarize yourself with those on page 314. Think of it as a game, but it's going to be homework, projects, logic as we move forward in the next couple sections. All right, thank you very much.